Aloha, Rich Alverson here. This is ITS128, and we're the air conditioning in Opico is down today, so we're doing this all online today. Nice to see you here. Let me share my screen. To All right. Now, I didn't. Let's see. So the last time, this is September 17th, so we're here, and I haven't covered chapter 3 yet, so I guess I'm uh, about 1 week behind, but that's okay, because really the deadline is the last day of class. So I'm gonna go into chapter 3 and do some of the challenges and have labs for chapter 3. So let's go to the text. Some of you have asked about participation verification or weekly activity, weekly engagement. We aren't doing that anymore because I only use that for participation verification, and that's over, and everyone was marked as participating. So thank you. So that's why you don't see that anymore. All right, so we're in chapter 3, and my okay, so um, we're done studying. We're done being exposed to the concept of a variable and an expression. You know, the variables on the left side of the assignment statement. An assignment statement assigns a value to a variable on the left. Assignment statement. So, and on the right side here, we have some sort of expression that calculates to something. And that something then is stored, is assigned. So this thing is assigned the value that this thing calculates to. So that's an assignment statement. So we've covered that. So now we're going to go to different types of variables. Okay, so as you know, there are sometimes you'll see 1, 2, 3, and it'll be the value 123. And other times you'll see 1, 2, 3, and it's the character 1 followed by the character 2 followed by the character 3. Takes up 3 spaces, 3 characters. Those are different types of variables, and you treat them differently. If it's a string of characters, you might concatenate that string of characters onto another string of characters. Like you might concatenate a string of characters that represents the last name of somebody onto a string of characters that represents the first name of somebody. Whereas numbers, like integers and numbers that have decimal points in them, those you don't concatenate, you add or subtract, or you do some operation. So strings are strings of characters. Okay, so let's find indicate which are string literals. This is a string literal. It's a literal is a term for meaning it's there's no calculation that needs to be done. It's just that's what it is. And this is a string literal. And this is not a string literal. Why? Because if it were a string literal, you would see little quote signs, quotes before and after, which means we're talking about the string of characters rather than the value. So this is going to be a no. So this, however, is a string of characters, you see. So that's a yes. All right, so let's go down to some participation. So do we have any challenges here? Some challenges. Enter the output of the string. So just start it up here. Okay, so print this string. Well, it's just as easy as can be. CID enter. Okay. Very good. Let's do the last one real quick here. So we have Vincent. So we are going to print out person 3. Person 3 is a string which consists of person 1 concatenated with person 2. So when we are dealing with strings, you see this is a string. It's not a number, it's a string. And then here we have another string. It's not a number, it's a string. When we use a plus sign in between them, we are concatenating. We're attaching the second one onto the first one. So this is just going to be Vincent Cloud. There's no space in between because there's no space here. There's no space after the Vincent. There's no space before the C for cloud. This is the Vincent. This is the cloud. We're just concatenating the two together, and this is what we get. This is a print statement, which means that we need to have this enter thing here. Okay, so check that, and that's the right answer. Where's the middle one? Okay, here, this middle one here, we're going to print. This is a function which returns the length, how many characters. So this one is a function. This is 1, 2, 3, 4, 5, 6, 7. 7 characters. That's the length of this string. This function will return or give us the length of that string. Well, the length is 7, so it's going to print out a 7. And then it's going to print the enter key because it's a print statement. And that one is correct. All right, let's do the next one here. Read this. Let's start it up. We're going to read a string and we're going to call it username. We're going to read a string from the input. We're going to put that string that we read from input into this variable here called username. And then we're going to read another one called, and we're going to put user age into there, and we're going to use this int because we're going to convert the string that the person types in into age and convert that to, and then we're going to convert that into an input, convert the input to read the integer. Let's see. Read the username input. Okay, so okay, so here's a print statement, and we're going to print some characters there, and then we're going to print some variable called username, and then we're going to print some more characters here, and then we're going to print the user age -7. So we're going to do this computation here, and we're going to print. We're going to read in the user age. Here we're going to read in the username, and we're going to read in the user age, and then we're going to output the username right here, a string of characters, and then we're going to output whatever this is. Like if you enter in like 50 and you subtract 7 from it, it's going to be 43. So this expression evaluates to 43, and it's going to print out 43 there. So it'll print out 7 years ago, this person was whatever that was years old. So first we want to read this in. So let's do that. We're going to say username is equal to something we read in. We're just going to do that. That's just inputting. We're going to input that. It's going to input the username first, and then we're going to input the user age. And so that's going to be user age equals input, but we want it to be an integer. So we're going to put that input inside of this integer function here. This is the argument of the integer of the int function, so this is going to take whatever this is, a string of characters, and convert it actually into a number, a value, which can be manipulated using math, using addition, subtraction, multiplication. Okay, so I think this is all we got to do, because we've read in username, we've read in user age, we've made user age an integer, so that way we can do this calculation here, see what we come up with. All right, got the points. Okay, so let's do this last one. Read the strings person name and birthplace from the input. Assign city string with the concatenation of the following. This concatenated with this, concatenated with this. Okay, so first I'm going to read person name equals hello. Yeah, hello. Yeah, okay, I wanted to check to make sure you can hear. Person name equals input. Okay, so that's going to read in a person's name. And then we're going to read in a birthplace. Okay, so birthplace, B-I-R-T-H, place, equals some input that you're going to enter in. And then we're going to print out this thing called city string. So I have to assign city string, cities string. That's this thing. Okay, equals the concatenation of this plus the concatenation of this plus the concatenation of, or concatenating this with this with this. Okay, so this is going to equal to person name, concatenated with, lives in, concatenated with birthplace. Okay, and this is what's inside. So I'm going to copy this and put it inside here. Now, you notice we have spaces here? That's because when we concatenate using the plus sign, it doesn't automatically add a space in there, just like it does if we were to use a print with commas. See, so for example, anyway, so let's see what this does. And we see that we got the right answer. If somebody types Ike as a name and the birthplace is Boston, Massachusetts, then it's going to output this. By the way, what does this example look like? Yeah, okay. All right, so that's strings. Okay, let's go to lists. Now, lists is you know how a string is like a string of single characters? A list is a list, just like a string is a list, except for the elements of a list can be anything. It can be any scalar value. Are we using the term scalar value? Check. Let me check. Types. Okay, we're doing lists. A list is, you can think of it like a container. It's got a list of things, and those things are in order. Okay, so here we have a list. It's a simple list. It's got two things in it. It's got the number 10, and it's got the string ABC in it. So a list can contain, anything in it, and it's a list of things, one after another, and those things can be any type of variables, any type that is supported in Python. So in fact, we know that a number is a type, so it can be a list of numbers, it can be a mixture, it can be a list of numbers and character strings. It can also be a list of lists. So this third one can actually be another list. Okay, so pretty versatile. So here's an example of here and the way you create a list is you just do it like this. Okay, this is going to be a list called prices. It's going to have three things in it. The first one is going to be this character string with three characters here, a $sign and a 2 and a 0. And the next one is going to be a number, 14.99. And the third one is going to be another number, and just an integer, 5. Okay, so this is how you write it, and it's going to allocate three different spots for it because there's three different elements in this list, and it's going to look like that. So you can click through this and see that works. First, we execute that, does that, creates prices, it creates this thing, puts that there. It's the name of the list. And then it's going to put these three things in order in the object there. And then at the end, it's going to, what does it do in the end? So price holds references to objects in the list. All right. So, see, or you can add Joe. Okay. That. Or you can add X equals 100. And you can add X and see what it does. Oh, look, there's the 100. So those are lists. Now it's got 5 elements. All right, so let's do some oh, this is how you refer to elements in the list. So here we have, this is an example of, we got 3 things here. This thing, the first one has this value, the second one has this value, and the third one has this value. Looks like these are cars. So then we're going to create this list called prices. And prices is going to have 3 elements in it. It's going to have, first one, it's going to have the price of this here Lamborghini. And then it's going to have the price of this here Bugatti. And then it's going to have the price of this here Aston Martin. And so it's going to be, 3.9 million, 2.4 million, and 1.85 million. And then this is a way that we can print them. We can refer to these different elements in the list. The list is called prices. We can refer to them using indexes. This is the 0th element, this is the 1st element, and this is the 2nd element. Actually, it should be, this is element index 0, which is the 1st element. This is element index 1, which is the 2nd element. And this is element index 2, which would be the 3rd element. See, so it's going to print out like that. Okay, so that's the way you can reference different elements in the list. By the way, you can reference different characters in a string the same way. Okay, you can have the string name, you can have these little square brackets and a digit in there or a number in there, and that's the index. That's the character at that particular index. So it's the same kind of thing. All right, to update lists, you can just change the particular contents of an element by saying, well, this is my nums here. My nums is element number 0 is 5, element number 1 is 12, and element number 2 is 20. Print it out. This is what it prints out. And then we come along, we're going to say, I'm going to say, I'm going to change element number 1, which is the 2nd element. I'm going to change that to minus 28. So you just do that, and lo and behold, now when you print out the same list, it's going to have a different value for the middle element. Okay, now, a principle here that we're learning is that this is a list, and you can change elements in the list. You can go in there and change one of the elements in the list, and then it's the same list, but it's just got a different value for one of the elements. Okay, so that, but with a string of characters, you can't do that. A string of characters, once you create the string of characters, if you want to change, like if the guy's name is Jan, guy's name is Jan, Jan, and you want to change it to John, Jon. You want to change the middle letter from an A to an O. You can't do that with a string. You got to create a brand new string. Okay, and the term for that in computing, in computer science, in programming languages, is that a list is mutable. You can mutate the list. The list can mutate into something else. It means it's changeable. You can change, row change. It's like just like the coronavirus is mutable. It evolves, it changes. Whereas a string is immutable. It cannot change. It's fixed. So if you have a string called Jan and you want to change it to a string called John, you got to create a whole new list. And then you just get rid of the old list. It's not that big a deal, but uh, it matters when we're passing variables from a main program to a function, or when we pass a variable from one program to another program. Um, if it's a mutable, then you can pass it, and then that little program can change it, and then when it comes back, it's different. Whereas um, if it's an immutable variable, and some things are immutable and some things are mutable. If it's mutable, then when you pass a variable to another function or something, it actually just creates a copy of it, and then the function itself can mess with it. But when it returns back from the function, the variable that you passed in does not change. It kind of reverts back to its original value. All right, so there's special functions that come along with lists for modifying the list by taking out an element, by adding an element onto the end, to popping an element off the front, uh, all that. There's a bunch of these different methods here. This will return the length of the list. This produces a new list by concatenating list 2 at the end of list 1. This will search the whole list and return the smallest value. This will search the whole list and give you back the largest value in the list. This will search the whole list and add up everything and give you back a sum of everything. This one, you have a list here, and you want to find where this value is. Let's say you have a list with a bunch of numbers in it, and you want to find 10. Then you want to find which one is a 10. You can do this, put a 10 in there, and it'll return the index of 10 if it exists. If it doesn't exist, it returns. I don't know what it returns. -1 or null. Nothing. What it returns? I can test it. Let's see, where's a good place to test it? Go back up here here. Okay, so I'm going to print names 1, and I get Roxana. That's names 1. And now what happens if I print names -1? Oh, no. I'm testing index. Let's take print names index Joe. So that's going to print the index of Joe, which is 0, 1, 2, 3. So that's going to print out a 3. After Roxana, it should print out a 3. And there you go. That's my 3. That's the index of Joe. Now I'm going to say, what's the index of Fred? There is no index for Fred. Let's see what it says. Bung. Oh, it gives me an error. That's not very fun. Okay, so you'll bomb your program. The program bombs. Well, we'll learn about how to keep programs from bombing even though there's an error. We will learn about that in exceptions. How to catch those exceptions. Anyway, so let's keep moving here. We're doing list basics. And I just did I have to do some let's do some challenges. Okay, let's do the first one here. We got a bunch of user ages here. Look at all those user ages. What is the value of the length of user ages? Well, let's see. 1, 2, 3, 4, 5, 6, 7. What's the value of the length of user ages? I would say 7. Very good. Let's do the last one. 9. Okay. User ages is this. What is the value of the sum of user ages. Not just some user ages, but the sum of user ages. Well, that would be 2 plus 5 plus 6 is 13. 2 plus 5 is 7, plus 6 is 13. So I'm going to put 13. Yes. Pretty easy. What's number 3? What expression creates this list? Okay, so we want to know how to create this list. Well, it looks like this list is the user ages 2, and concatenated onto the end of that is user ages 1. So it's going to be user ages 2 plus user ages 1. Is that here? Yeah, it's this one here. User ages 2 plus user ages 1. All right. So you can do 2 and 4. Let's do this one. 2 ages are read from input into variables age 1 and age 2. Age 1 and age 2. Then 2 names are read from input into variables name 1 and name 2. Okay, so we've got name 1, and it's going to just read in a string of characters, which is someone's name, and then name 2, same here. Create a list of named ages list to hold age 1 and age 2. Okay. First, create a list named ages list. Ages list containing age 1 followed by age 2. Okay, all right. And what about names list equals name 1 followed by name 2? Thanks. Good. Print ages list, print names list. Okay, that should work. All right. It worked. Let's do number 3. Okay. Okay. Here we, did I do this one already? No. Here we go. Number 3. Okay. List, months list is created with the first 4 strings read from input. Remove string 7 from months list, then read an additional string from input and append the string to months list. Okay, are we just assuming that 7 is going to be in the list? Yes, we are. What happens if it's not? Okay, so all right. So there's months list. And then I got to remove string 7 from list. So I'm going to do this. Let's go back. Let's see how to remove something. Remove. Pop. Remove. List removes the first element whose value is V. Okay, so I want to use this one. List remove V, and for V, I'll put a 7. Okay, list remove V. Okay, so it's going to be months list. Remove 7. Oh, wait a second. It's got to be quote 7. Why? Because these are strings that are read in, not integers. If they were integers, they'd have an int around them, And then I wouldn't put the quotes. I put a value there. But these are going to be strings being read in, so it's characters. So it's got to be, if I want to refer to a literal string, I put quotes around it. So I'm going to remove the 7, and then I'm going to append. Oh, then I got to read in something. Read additional string from input and append it to the strings list. Okay, I think I can just do months list append input. Am I reading in a character? Yeah, character. Okay, input. So this will read in an input and append it onto the end of the list after we remove the 7. Let's see, is that right? I want to append. Is that how I do append? Append, yes. Just like this, append, parentheses. I want to make sure it's parentheses, not brace. All right, so this looks like this will work. Check. Very good. Let's see what the last one is. The list, this, is created with the first 2 cities read from input. Okay, so that's this. Reads the first 2 cities from input. Then list 2, cities list 2, is created with the last 2 cities read. Okay, that's a second, whatever. Create a list called 3, which concatenates list 2 at the end of list 1. Then assign a variable called located index with the index of the element Santa Fe in cities 3. Okay, so first I've got to create a cities 3. List 3, which equals cities list 1 concatenated with cities list 2. Okay, so I did that. End of cities list 1. Then assign a variable called located index. It's this. Okay, so then assign a variable called located index. That's a variable, and what am I supposed to assign it? The index of the element Santa Fe. So this is the element that's in cities 3, but we're supposed to find it. Oh wait. Then assign a variable called located index with the index of the element Santa Fe in cities list 3. Oh, cities list 3. Okay, so this is the final list. Okay, not 1 or 2, but 3. So wherever Santa Fe is in 1 or 2, it's going to be in either 1 or 2. So that means it's going to be in 3 because 3 is a concatenation of 1 and 2. So this is just simply going to be cities list list 3, the location of the index of Santa Fe, which was that. So find the index of Santa Fe inside this list. This list, which is the concatenation of 1 and 2. So that means Santa Fe has got to be in 1 or 2. Otherwise, we're going to get that nasty error that we saw before because it's not in there. So I'm going to run this and see what happens. And of course, they only test it on ones that have the index, have it in there. So there's 2 of them in there, but it's going to return the first one. All right. Tuples. Tuples are like lists, except for, you can pronounce it either tuple or tuple. You can pronounce it either way as far as I'm concerned. It stores a collection of data, like a list, but it is immutable. Remember what I said? It means you can't change it. Once you create the set, it's it. You got it. That's it. You can't add to the set. You can't do anything to the set. Do anything to the set. If you want to add to the set, you actually have to create a new set that contains the old set plus the new element that you want to add to it. and it's not in any, oh no, a tuple it does have, okay, so yeah, a tuple has an order. Sets, well, when we get to sets, we're going to see sets are like tuples, except for they don't have an order. Anyway, so a collection of data like a list, except for it's immutable. Once created, the tuple's elements cannot be changed. A tuple is also a sequence type. It means it's got an order, it's got a length, it's got indexing. There's a first element, there's a second element, there's a third element. Um, other ones there's not. This one there is. And there's sequence functions too. So you can go through you can talk about an order or a sequence of values in a tuple, and it makes sense. So here we're White House coordinates. That's the coordinates of the White House, and so it's a tuple is designated by parentheses like this, and so that's how that works. So you refer to the elements of the tuple because they're sequenced. Create a new variable point that is a tuple containing the strings X string and Y string. So a tuple called point equals X. Is that a capital X? Yes, it is. Oh, it's a string. I think. Yeah, I think it's going to be this. You're going to come out a single quote. Okay, so this is, if you can read it, I'm going to put a space here, space here, space here. It should be okay. X string and Y string. Let's see if this is right. Ah, it is right. Okay, great. Okay, let's keep moving here. Of course, it doesn't have to be, they don't have to be all the same type, numbers or character strings. Here is a tuple that's got two elements, this element and this element. The second element, however, is a list, in case you didn't notice. Hmm. Um, okay, I got to use this named tuple thing. And I am not really used to the named tuple allows the program to define a new simple data type that consists of named attributes. A named tuple container must be imported to create a new named tuple. Okay, well, anyway, so first we have to import this method function called named tuple, and then we can create a new car, which is a named tuple. This would be a named tuple. It's got a name. Okay, so anyway, I don't know, named tuple. Yes, tuple. That's all right. So let's do some of these here. Color is a named tuple with fields name, R, G, and B. Variable color, an object created with one string and three integers, read from inputs as attributes. Output the following. Um, hold on, I'm gonna real quick grab something to drink here. All right, so we're gonna input one, input two, input three. So it's a name two. Okay, so my code goes here and it's supposed to print out color name and R, G, and B. And we're supposed to print. Okay, well, I'm not. This is okay. So I'm gonna try to see what I can do. Okay, let me just do this. So, do I have to? All right, so I think it's this. What did I not do? Did I not start this? Okay. All right. So I think I can do print F color name colon colon space, and then I got to do this color dot name. Yeah. Okay. Yes. Okay. This. And then I would say R print F R colon space squiggly color R end quote, and then print B paste paste. This is G and this is B. Red, green, blue. All right, I'll see if this works. Well, I wish I knew what I did. Let's do this one. Import the name tuple container from collections. I got to do that. First, I got to put that there. And then define a named tuple called persons with fields like that. Now I got to create a named tuple. Looks like this. But it's not going to be that, of course. It's going to be Can I do this? Did I not start it? Oh, I gotta put it up here. Oh, good, good, good. Okay. Okay, so I'm gonna called person, name tuple. What does it look like? Mia Tran. Okay, first name Mia. First name Mia. Okay. First name Mia. Last name Tran. State, person state, license plate. This is all I have to do. Wait a minute, that's not right. No, I forgot to put everything in here. It's not this. It's name tuple is person. This is called person. And this is called first name. Okay, so these are I think these are in quotes are going to be the actual names of the fields. Is that right? Yes, these are in quotes. Yeah, right. This is the make, and this is the model, and this is the price, horsepower. Okay, so I think this will work. Let's see if this works. Oh, good, I got it to work. All right, let's do this one. See what this looks like. School is a name tuple with the fields name, city, state, enrollment. Read the three strings and one integer from the input. The three strings are name. Okay, so I think it's going to be something like name equals input and city equals input and state equals input and enrollment equals input. I think I need one more thing. I think I need school equals school All right, I'm gonna see if this works. All right, well, you can do this one, number two. Here we're referring to elements in a different way. So anyway, you can figure that one out. All right, what's next? Set basics. Okay, so sets are like tuples, except for there's no order. Iced tea. And the elements are unique, which means there's no duplicates. Unordered and no duplicates. Um, Sets are mutable. Okay, it means you can change them. It means you can remove them. You can remove an element. You can remove and pop, remove an element from the list. There's no order, so this must be a value in here that's in there. You can add an element to a list and so on. This is how you concatenate, or it's not the same. I guess concatenate you can call it. Adds elements in set 2 to set 1. So here we have set 1 and we want to add these elements to set 2. Remember, there's not going to be any duplicates though. This just adds a value to the set. This removes a value from the set. It raises an error if the value is not found, and that could be raise an exception, and you can deal with it that way. We'll learn about that in chapter 10. This removes any old random element from the set, and this clears a set, makes it all 0. Sets looks like they're defined, enclosed in these curly braces. And then here, when we add a set, we use parentheses. We update here. This update adds a set to a set. Add just adds a single element to a set. Remove just removes an element from a set. All right. Okay, so here we would use the add. And here we would use the update. Okay, so here's some common set operations. You can take the intersection of two sets, and that would be the elements that are contained in both sets. This is the union of sets. That means you take the elements of all the sets in here, and the new set it's got all of those elements in it, except for there's no duplicates. This is a difference where you take a set containing only the elements of the set are not found in any of the other ones. So somehow. Okay. Return a set containing only elements that appear. Okay, so this is a symmetric difference. This is a different. It returns a set containing only elements of a set that are not found in any of the sets. Take this set, that's a set, and then you subtract out all of the elements. If there are any elements in any of these sets that are also in this set, those elements are taken out. The only elements that are left are the elements in this set that you don't find in any of these other sets. So that's a difference. And then this is returns a set containing only elements that appear in exactly one of the sets. Interesting, symmetric difference. Okay, explain some of that. Okay, let's do some of these challenges here. variables person one, person two, and person three are read from input to create a set named unique names containing person one. Okay, so it looks like because sets are unordered, sets are printed using the sorted function. Okay, great. So we want the symmetric difference, don't we? Create a set of unique names contained in that. So that sounds like a symmetric difference to me. Returns a set containing only elements that appear exactly in exactly one set. Yes. Well, I'm going to try it. This unique names, symmetric difference of. I wonder if this will work. Uh, yeah, I don't know if this is going to work. I'm going to see if this works. No. Oh, I forgot to do the. I got to do union. No. Union is what I want to do. Is that. Yeah, I gotta. All right. I don't. I'm not sure I can get this right, but I'm gonna do this equals. Um, this is set. Wait. All right. So first, I'm going to create a list. It's like this, and I'm going to. I'm going to see if this works. Oh, it works. Hmm. All right, boy. Okay, I'm gonna just do the next one. All right. Set names remaining. Is the set that is initialized with three names and read from input. Okay, so press this out, and and that, and that, and that, and then we're supposed to remove. Let's see. So we're gonna do names remain, and I think I can just use remove. Remove. Remove val. Then assign num names with the number of elements remaining. So I guess num names equals um, let's see, I can't remember what the number is. It is the len, len. Len names. Okay, let's see if this is right. Okay, might as well do it's 252. I'm gonna do the next one. Also, okay, set animals, animal set contains zebra, set two, just contains an empty set. And then we add something and we add something. Perform the following tasks. Update animal set one with animal set two. So we take animal set one, that does that. Then read the next string from input and remove the string from animal set one. Okay, so then read the next string from input and add the string to animal set one. Oh, okay. Is that right? Remove and add. I'm pretty sure that's right. Let's just see if it is. Okay, let's see what this is. All right. Let's see what the last one is. Okay. So my favorites contains this. Set your favorites equal to three things that are read in. Integers, 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 integers. Assign numbers not shared with a set containing only elements that appear in exactly one of my favorites and your favorites. So it would be numbers not shared equals something. Symmetric difference, maybe? Exactly one. Oh, wait, no. Exactly one. Okay, yes. So this is exactly one. So I'm going to call it returns a set containing only elements of a set that are not found in here. Okay, so intersection common. These are only common ones. These are all of them. These are ones that only appear once. Okay, so I'm going to do this. My favorites. Um, Set difference. What's this one here? Symmetric difference of your favorites. Okay, let's see what this does. Okay, yours might be a little different. I'm looking at another example of another version of this challenge activity here. So hope this helps you. Let's see, are there any other ones here? Okay, so we're done with we are done with okay, so I'm gonna do dictionary basics and then I think that might be it for today. Okay, creating a dictionary is uh an element, each element of it, it's kind of like a set. Each element of the dictionary has got it's got a key value, a key and a value. So it's like this is a dictionary that's got two elements in it. It's got a key value, which is this, a key, which is this, and this is a value. So key Lionel Messi, that key's value is 10. This key, Cristiano Ronaldo, Cristiano's value, Cristiano's a key, the value is 7. So it's like if let's say these were ages, okay, this Richard Halverson, age 39, I'm a little over 39, or my wife, age whatever. So that this can be the key is the name and the value would be the age, for example. Key value pairs. And you use curly braces just like you do for a set. These are curly, but these look different. So this is an example of creating a dictionary, key value pairs. And here's a dictionary that's got 1, 2, 3, 4, 5, 6, 7 elements in it. Got keys and values, and keys and values. And this is how you refer. This is the name of the dictionary. And if you want to find the value of apples, that's how you do it. The value of apples is that. There's no lemons, so you're going to get an error. Okay, adding, modifying, and removing dictionary entries. If you want to add a value, if you want to add an entry to a dictionary, you just say the name of the dictionary, the key is equal to a value. The name of the dictionary key is equal to a value. So this is a dictionary called students, and it contains student grades, and the key is the name of the student, and the value is the grade for that student. Modifying existing entries, it's mutable. Dictionaries are mutable, so you can change existing entries. Here you can change the person's value. This is how you delete a dictionary value. You just use DEL and then the name of the dictionary along with its key value. This is how you delete Rachel, the student called Rachel, just like that. And very good. Okay, so let's do these things right here. 3 integers are read from input into variables, red channel, green channel. Okay, so 3 integers are read into here. Create a dictionary named color code, which contains the key value pairs, RGB. Okay, so we have read in red channel, read in green channel, read in blue channel. Create a dictionary called color code, I guess. Color code equals, by the way, you're going to be using dictionaries a lot. You're not going to be using sets very much. You're not going to be using tuples very much. You're going to be using lists a lot. And you're going to be using dictionaries a lot. So this is going to be R colon red channel, comma, right? It's comma, not semicolon, right? Yes, it is. And then it's going to be red green, green channel, and then blue channel. And you might want to make consistent spaces and so on, but as you know, it doesn't. Personal preference. Okay, so yeah, let's see if this works. Looks like it should work. Very good. Oop, no. Oh, should be curly. What? Did I write that? What? Oh, never mind. This should be a curly. That's better. Okay. All right. What's the next one? We have room guest pairs. These are the rooms and these are the guests. So in this case, the key is this integer value, and the key is this integer, and the value which corresponds to the key is this string of characters. Read a room number from input. Read a room number. Read a room number from input, then output the corresponding guest's name from the room guest pairs. Output the corresponding guest's name. Print room guest pairs room number. Okay. That's going to print out the value associated with room number. Okay, and let's see this works. Nope. What did I not do? Did I not remove somebody? Oh, I'm supposed to remove somebody. Then delete that pair from the, okay, so I got to delete that pair. How do I delete the pair? I just go, DEL this. I want to delete that. Okay, let's see if this works. Yeah, there we go. I deleted it. Okay, what's the next one? Dictionary food quantities contains 4 key value pairs. 1, 2, 3, 4. Read a string from input representing the key found in food quantities. I'm going to say key found equals um, string from input, not an integer, but a string. Uh, then assign the value associated with the key read with the current value -1. Okay, so now I'm supposed to do food quantities equals, no, no. Food quantities of key found is equal to food. I'm supposed to just add 1 to it. Oh, I'm supposed to subtract 1 from it. Okay, I can just do this. Minus equals 1. How's that? See if this works. Oh, worked. Oh, that's fantastic. Let's do the last one, and we'll be done. Okay, got a dictionary called that. It's got a bunch of elements in it. Looks like it's got 12 in it. Read integers start from and end at from input. Start from equals integers, int input, and then end at equals int input. And then use time to word to access the corresponding words of each integer. Then output a starting time. Okay. Then out, let's see. Okay, so if I input 5, 8 to 5, okay. So I'm supposed to go, print, um, time to word of I want to go the opposite way, don't I? How do I do that? Okay, let's see. How do I do that now? I think I gotta figure out what the value is. I need to go. I'm supposed to print out the 1 and on the key value. Let's see. Find the key whose value is. I need to find the key whose value is All right, I was reading this wrong. It's simply the key that in start from. Start from. Okay, I was getting these mixed up. I was thinking the one was the key and the two. I was thinking the one the word was the key and the integer was the value, but it's the other way around, just like up here was the other way around. Anyway, let's see if this is correct. Yes, that's correct. All right, this was a much simpler problem than I thought it was. Okay, so anyway, we have gone up to 3.5. And so now I'm going to talk about next video I make, I'm going to talk a little bit about conversions, how you want to convert from one type to another. Like we've been doing a lot of converting from strings that look like numbers into numbers, but there's other kinds of type conversions that go on too. And sometimes we have to be explicit about doing it. And then I'll go over these labs here. So anyway, so we've gone over a little bit today, and are there any questions? Anybody have any questions? Okay, I will. I need to update this your scores. I need to upload the scores from Zybooks, but I'll do that later today. And anyway, I hope this helps. See ya next time. Bye.